Hello, viewers. In today's session, we are going to discuss another important problem from definite integrals. And in this session, we are going to establish this important integral inequality using properties of definite integrals. So here we have to establish that the value of this integral, that is integral from pi by 4 to pi by 3 sine x dx, it lies between these two numbers, that is pi over 12 times square root of 2 and pi root 3 divided by 24, right? So let us see how easily we can establish this integral inequality using an important property of definite integrals. So let us first state the property. Suppose we have a function, say y is equal to f of x, which is a continuous function in the interval that is a comma b. And let us suppose that this function y is equal to f of x has a minimum value as small m. So small m denotes the minimum value of the function f of x in this closed interval, that is a comma b, and the capital M denotes the maximum value of this function in this interval, right? So here we have the property that is m times b minus a is less than or equal to the integral from a to b, and here we have f of x dx, and this integral is less than or equal to capital M times b minus a. So this is an important property of definite integral, which states that if we have a continuous function y is equal to f of x defined in some interval a comma b, and small m denotes the minimum value of f of x and capital M denotes the maximum value of f of x, then the value of this integral is greater than or equal to this product, that is m times b minus a, and this integral is less than or equal to this product, that is capital M times b minus a. So here we are going to utilize this property to establish this integral inequality. So let us first take the integral that is pi by 4 to pi by 3 sine x dx as I, right? So here we have this integral, and if we compare this integral with this one, that is from a to b f of x dx, then we can easily see that the limits, that is the lower limit a is pi by 4, the upper limit b is equal to pi by 3, and the function f of x is the sine function, which is a continuous function in the interval, that is pi by 4 to pi by 3, right? And moreover, here we can easily see that this function sine of x is an increasing function in this interval, because if we find the derivative, that is f prime of x, then here we have the derivative of sine x is cosine x, and this derivative f prime of x is greater than 0 for all values of x belonging to this interval, that is pi by 4 to pi by 3. So now let us find out the value of small m. So small m is the minimum value of f of x, and f of x is sine x. So here at this point, that is pi by 4, we have the minimum value of this function sine of x, right? We are here confining ourselves to only this interval, right? So the minimum value of sine x, it occurs at this point, that is x is equal to pi by 4. So here we have sine pi by 4. So this is 1 over square root of 2, and the value of capital M is the maximum value of f of x. So here the value of capital M can be obtained by taking x is equal to pi by 3 in the function f of x. So here we have sine pi by 3, and this is sine 60 degrees, and sine 60 degrees is equal to square root of 3 over 2. So now let us substitute these values in this inequality. So here we have small m times b minus a. So small m is 1 over square root of 2, and b minus a is given by pi by 3 minus pi by 4, and then we have less than or equal to. Then we have the integral from a to b. So here we have pi by 4 to pi by 3, and here we have sine x dx, that is less than or equal to capital M times b minus a. Capital M is square root of 3 over 2, and here we have pi by 3 minus pi by 4, right? So the difference pi by 3 minus pi by 4 is given by here we can take the LCM, that is 12. Then we have 4 pi minus 3 pi, that is pi over 12. So substituting the value of pi by 3 minus pi by 4 as pi over 12, now this inequality can be written as 1 over square root of 2 times pi over 12, and then we have the integral pi by 4 to pi by 3 sine x dx, and here we have square root of 3 over 2 times pi over 12, right? So solving these two terms, we can now write pi over 12 root 2, and here we have the integral pi by 4 to pi by 3. This is sine x dx, and here we have pi root 3 over 12 times 2 is 24, and this is our required inequality which was to be established. So viewers, this is how by using this important property of definite integrals, we can easily establish these kind of inequalities. Hello viewers, in today's session we are going to discuss another important and very conceptual problem from definite integrals. And in this session we are going to discuss this problem where we are given a function f which is defined from this set, that is the closed set from 0 comma 1 to the set of real numbers, and we are given this integral, that is 0 to sine x f of t dt is equal to square root of 3 divided by 2 pi x square, and we have to find the value of f of half, right? So here in this session we are going to make use of the famous Leibniz integral rule to solve this problem, right? So let us first see the statement of Leibniz integral rule, and then we'll see how we can easily solve this problem using the concept of Leibniz integral rule, right? And moreover here this domain, that is the function f has this domain, that is the closed set 0 comma 1, and this domain is going to play a crucial role, right? So let us start. Now, Leibniz integral rule states that if we have an integral whose upper and lower limits are functions of x. Suppose the lower limit is u of x and the upper limit is v of x, and here we have a function f of t, and here we have dt. Now suppose we wish to differentiate this integral with respect to x, then Leibniz rule says that first we'll replace this t by the upper limit, that is v of x. So we have f of v of x, and then we differentiate this function v of x with respect to x, then we have a negative sign, and then we replace this t by a u of x. So we have f of u of x, and then we differentiate u of x with respect to x, right? So when we have a function f which is a function of only t, right? So here we are considering this function f of t only, right? So then this Leibniz integral rule goes like this, right? So here we are given this integral, that is 0 to sine x f of t dt, and here we have square root of 3 over 2 pi x square. So here the lower limit is 0 and the upper limit is sine x. So the upper limit sine x is a function of x. So we'll differentiate both sides of this equation with respect to x. So now differentiating both sides with respect to x, we can write d by dx, and here we have 0 to sine x, and here we have f of t dt, and in the right hand side we have d by dx of square root of 3 over 2 pi and x square, right? So if we compare this integral with this one, then u of x is 0 and v of x is equal to sine x, right? And if we apply this rule, then the left hand side can be written as f of v of x. V of x is sine x, and then we differentiate v of x with respect to x. So we have d by dx of sine x, then we have the negative sign, then we have f of u of x. U of x is 0, and then we differentiate u of x with respect to x. So we have d by dx of 0, and in the right hand side we have square root of 3 over 2 pi, and the derivative of x square with respect to x is 2x. So now simplifying this side, we have the derivative of sine x as cosine x. So we have f of sine x, and here we have cos x, and this term is 0 because here we have 0, and now we can write root 3 over pi, because this 2 and this 2 get cancelled, and here we have x, right? So using the Leibniz integral rule, we have arrived at this equation, right? Now see here we have to find f of half, right? So here the input is half, and here we have f of sine x, right? So in order to get the value of f of half, let us replace sine x by half, right? So taking sine x is equal to half, this equation is now taking the form f of half, and then we have cosine x, and here we have root 3 over pi, and here we have x, right? So now we need to find out the value of x, and to get the value of x, we'll utilize this relation, that is sine x is equal to half, and this is a trigonometric equation. So sine x is equal to half. It gives us x is equal to pi by 6. because sine of pi by 6 is equal to half, right? And we can see that this x, which is equal to pi by 6, it belongs to this interval, right? So pi by 6 belongs to the interval 0 comma 1. And if we find out the value of pi by 6, then it is approximately equal to 0.523, and 0.523, it belongs to this interval, right? Now see here, sine x is equal to half is a trigonometric equation, and we know that sine x is a periodic function with period t is equal to 2 pi, right? And sine x is equal to half has many solutions, but here x is equal to pi by 6 is the only solution which belongs to this interval or this domain, right? So we have to take only this value of x, that is pi by 6. So now taking x is equal to pi by 6 in this equation, we have f of half, then we have cos of pi by 6, and here we have root 3 over pi, and x is pi over 6. And this pi get cancelled, and we have f of half, and cos pi by 6 is cos 30 degrees, that is equal to root 3 over 2, and here we have simply square root of 3 over 6. So now we can rearrange the terms. So we have f of half is equal to root 3 over 6 multiplied, and here we have 2 over root 3. Now root 3 and root 3 get cancelled. Here we have 2 times 3 is 6, so we are left with 1 over 3. So viewers, the required value of f of half is equal to 1 over 3. So this is how, by making use of the Leibniz integral rule, we can solve these kind of problems comfortably.